Hello, math students. We're still working in Module 1 called Ratios and Proportional Relationships, and the name of our lesson today is Identifying Proportional and Non-Proportional Relationships in Tables. This is Lesson 3. Our goal is today we are going to learn how to check if a table is proportional or not. The question that I want you to be thinking about while we go through these notes today is, what can you use to determine if a table is proportional? And that will become very in handy towards the end of trying to figure out whether the table is proportional or not. So the first thing that we need to do under the Things to Learn section is remember what a ratio table is. And a ratio table is usually made up of two columns. And the column on the left side is called the input column, and the column on the right side is called the output column. The input column is the amount that goes in, or that you start with, and then you change this value somehow, and however you change it, that's what spits out the output, or the answer. Okay? Usually your X values are on the input side. Usually the Y values are the ones that result, or so we changed the X and we got the Y. We changed the X and we got the Y. We changed the X and we got the Y. We changed the X and we got the Y. We changed the X and we got the Y. So this little cloud is here to help us remember the rule. Plug in the X value, multiply it by the constant, and then you get the Y value. And that's basically the rule that happens. So if we look at this table to figure out if there's one specific rule happening, we do that by checking every single value. So we have 1 times something gives us 2. So inside your head right now, you should be thinking, oh, well, that's easy. 1 times 2 gives me an output of 2. Then we're going to try the next one. What number times 2 gives me 4? Oh, well, that's pretty simple too, times 2. What number times 3 gives me 6? Again, it's times 2. What number times 4 gives me 8? Again, it's times 2. And what number times 5 gives me 10? Times 2 again. Okay? And so we have just figured out that all of the values on the X side were multiplied by the same number. When they're all multiplied by the same number, that is what becomes your constant value, the amount that they multiplied it by. So another thing that we can do is we can set up this little sentence frame to help us check them. So 1 times 2 equals 2, 2 times 2 equals 4, 3 times 2 equals 6, 4 times 2 equals 8, and 5 times 2 equals 10. And then the question down at the bottom says, what is the constant? And so the constant amount being multiplied to every X value is 2. Okay? And so the answer on this one is that every X value that's listed on the X side, every X value has been multiplied by 2. So the constant value being multiplied is 2. Okay? All right, so now let's look on the next page because we have one more page that we need to do really quickly. If all X values are multiplied by the same number, then that is the constant. So the number that was constantly multiplied on the other side was times 2. So our constant for this specific ratio table is multiplied by 2. The thing that you need to know about that is that if it multiplies it all by the same number all the way down the table, then that proves proportionality. So we can say that this table right here, 1 to 2, 2 to 4, 3 to 6, 4 to 8, 5 to 10, that is a proportional table. It's a proportional relationship because the amount that we multiplied to every single one of the values was 2. So it makes it proportional. Okay? So we're going to practice one over here. It says wedding dinner. So we have the number of enchiladas and then the number of guests. So our job is to ask ourselves, is this relationship proportional? And so we want to know, is the relationship between enchiladas per guest proportional? Okay, so the way we have to check is we have to ask ourselves some questions again. We're starting with 10 this time, but it dropped down to 5. So you can multiply or divide. Those are the only two things that you can do in this specific instance. So what number you take 10 and divide it by this number that gives you 5. 10 divided by what number is 5? I'll say it again. 10 divided by what number is 5? If you said 10 divided by 2 equals 5, then you are correct. What number, 100, divided by what number gives you 50? If you said divided by 2 again, you are correct. 300 divided by what number gives you 150? If you said divide by 2 again, then you are correct. Okay? And then 3,000 divided by 2 gives you what number? If you said divide by 2 again, you are correct. 2 divided by what number gives you 2? Uh-oh, it's divided by 1. So here is the question that we have to ask ourselves. Is this a proportional relationship? And let's write it down here. 10 times, we've got to talk about that because I wrote times, and the reason why I wrote times is I want to teach you one more thing. Did you know that when you divide a number by 2, it is the same as multiplying by 1/2? Okay, and I wouldn't just take Mrs. Nelson's word for it. Let's try it. So what if we had 4? Boys and girls, what is 4 divided by 2? 4 divided by 2 is 2. We've already talked about that. Now, what if we took 4 and we multiplied it by 1/2? Well, if you remember multiplying fractions by whole numbers, you have to make 4 a fraction. So we say 4 over 1 makes that a fraction. And then you just multiply straight across. 4 times 1 is 4. 1 times 2 is 2. And then you have another division problem right there. 4 divided by 2 equals 2. So did we just prove that when you divide by 2, you get 2? When you multiply by 1/2, you still get 2. Okay, so it's very simple to remember that dividing by 2 is the same as multiplying by 1/2, and it actually works for every number. So if you're dividing by 3, what do you think that's the same as? It's the same as multiplying by 1/3. Okay, if you're dividing by 4, it's the same as multiplying by 1/4. If you divide by 5, it's the same as multiplying by 1/5. What if you're dividing by 1,000? It's the same as multiplying by 1/1000th. Okay, so I hope you're starting to see the pattern that whenever you divide by the number, it's the same as multiplying by its reciprocal. Okay, so when we fill out this table over here, 10 times 1/2 gives us 5. Well, let's test it to make sure that you believe me. So 10 over 1 times 1 over 2. Let's see what we get. Okay, so 10 times 1 is 10. 1 times 2 is 2. 10 divided by 2 equals 5. Did it work? And the answer is yes. Okay, so now 100 times, you got it, 1/2 gives us 50. So then what goes right here? You're going to say 300 times 1/2, and that would give us 150. Sorry, that's my kitty. She's visiting. All right, and then we have 3,000 times 1/2, and that gives me 1,500. And then we have 2 times 1/2 does not equal 2. So here's the problem. This guy right here messes up the table. And why does he mess up the table? Because remember what I told you in the other example. If all of these are the same, then you have a proportional relationship. But this one right here is not the same, so it is not a proportional relationship. It is not a proportional relationship. So is the wedding dinner scenario a proportional relationship? The answer is no, and your reasoning is because you do not have every single one multiplying by 1/2 or dividing by 2. This little guy down here messes the whole thing up. Okay? All right, kiddos. So now let's go back and see if we've met our goal. Our goal is today we are going to learn how to check if a table is proportional or not. And what did we learn? We learned that if every input value is multiplied or divided by the same thing, then you have a proportional relationship. If it is not the same thing, then you do not have a proportional relationship. So this one would be not proportional. This one is proportional. Boys and girls, do you see that? Okay. And then the question, what can you use to determine if a table is proportional? What did we use? Everybody needs to remember. I'll give you a big hint. It's in the cloud. What did we use? Okay. We used the idea that having a constant value multiplied by every value in your table proves that it's a proportional relationship or not. Okay? All right, kiddos, that's all I have for you in this lesson. I will see you all later. Bye.